we would proceed in vector calculation. We would proceed in vector in introduction of vector in parameterization of surface in calculus. How, how a vector makes sense when we are in discussion for the parameterization in calculus. So that is in question. So how much the vector introduction of vector matters in parameterization in calculus. Parameterization of surface in calculus. Addition of vector changes the taste of the food. Like meat changes the taste of the food. I mean, this is not a good custom nowadays to talk about meat. Fruits. So, fruit changes the taste of the food. This is what I can say. So, vector changes the vector means meat changes the taste of the food. Taste of so if we see the calculus, then algebra is based upon numerical, and upon algebra, so there is a numerical science, numerical mathematics. On top of it, there is algebra. Algebra is in different form: Cartesian coordinate system, polar coordinate system, cylindrical coordinate system, spherical coordinate system. And on top of algebra, the algebra is manipulated through calculus. And on top of algebra, there is vector. So vector is something that uses algebra and make more shining into the mathematics. So vector is nothing but a energy which has a direction and which has a magnitude. So a vector has its component, first component, second component, third component. If I have a capital F is a vector, then F1i plus F2j plus F3k. So that is the capital F, F1i plus F2j plus F3k. It can be more on it. If that is the scenario, if that is the scenario, then it is the components f1, f2, f3. It can be algebraic. So now algebra is embedded inside the vector. So vector has its component and not required that component will be the numeric one, 2y plus 3j plus 4k, not required. So in that case, we have kind of the component. If I have algebra, so vector field, it is not required. It can be 2i plus 3i plus 4j. It can be xi plus x plus yj plus sine square xk. It is in algebraic form. So algebra is promoted to vector form. Vector had its component as algebra. So we are in discussion for the parameterization. So parameterization, if I do parameterization, or if I do in kind of calculation, now what we were doing, if you remember, we were calculating the curve length of a circle. If I have a circle, then what is parameter? So if I see that, then equation of circle, that is fx, that is y, equal to square root of a square minus x square. That is calculus way of talking, where x is independent component and y is dependent component. So if I talk in kind of dependent independent, I have y as dependent upon x. Now, if I try to calculate any, what is parameterization? Then we will proceed in it. Parameterization is nothing but if I have independent component and I have dependent component, then if I need to do integration of this dependent component with respect to independent component, fx dx, that is the integration. Like square root of a square minus x square dx. Integration is not similar to differentiation. Differentiation, product rule, chain rule, they break the matter, and slowly, like a square minus x square square root, if I differentiate with the product rule and chain rule, then it will become 1 by 2 a square minus x square to the power minus 1 by 2, and then again differentiation of a square minus x square with the x. But this is not possible in integration. It is not that straightforward. So two ways in integration. Product rule in differentiation, it maps to it product rule in differentiation, it maps to integration by part, and then chain rule. So whatever we are doing in differentiation is first we differentiate with a square minus x square in chain rule, and then we differentiate with a square minus x square with x. In integration similar to it, if product rule has similarity in integration as integration by part, then chain rule has similarity in integration as method of substitution. I can substitute a square minus x square with y square. In that case, y square square root will be y. What will happen to dx? So, anyway, now consider a square minus x square. I am substituting with y, or I substitute with u. So, now I have y equal to square root of a square minus x square, where square root of a square minus x square, where a square minus x square equal to u, or x equal to some function of u. I have y, it is function of x. X is independent component, y is dependent component. Can I bring this is x, this is y, can I bring u, another component that is independent component, x is dependent upon u. So x, y, upon x, y is dependent and they are related through a function. X is independent. Can I bring another one that is u, and x is dependent upon u and they are related through a function? So if y equal to function over x fx, then x equal to gu. This is method of substitution and it is counterpart of chain rule in differentiation. So all story starts from here only. How to simplify method of substitution in integration. So that is the concept, that is something that always hits a person. How I can proceed in the method of substitution. How I can proceed in the method of substitution. Okay, if that is the case, then consider x equal to a cos theta. Cos u, x equal to a cos u. This proves that now x is a function over u. X is dependent, u is independent. Whereas originally x was independent and y was dependent. Y equal to square root of a square minus x square. So y dx, fx dx. Now, since I don't know the integration of a square root of a square minus x square, x equal to a cos theta, then it becomes a square root of 1 minus cos square theta, a sin theta. Now I have to integrate a sin theta. What about dx? How I can change dx into theta? Dx is nothing but dx by d theta into d theta. So if I differentiate dx with d theta, then whatever I get, that I have to replace and d theta. This dx by d theta, dx equal to dx by d theta into d theta. This dx, the variation of x with respect to theta, this is some loosely it is called Jacobian. Jacobian means if I introduce another independent variable u against x, and x is a function g of u, then what is dx by du? If I make unit change in u, how much x would change? Dx is replaced by dx by du into du. Now x equal to u cos theta. So u cos u. So u cos u du cos d a cos u by du, that will become minus a sin u. Now full term would become a sin u into minus a sin u du. So minus a come out, minus a square. Now integration is minus sin u minus sin square u du. Now someone can do its integration, minus sin square u du. Whatever comes, then someone can bring it back in x, and then lower limit, higher limit, whatever it was there. So we used u only for the doing the integration. Once integration is done, result is out, take it back into the x. This is one way. Other way is leave it in u only, and whatever the limit was in x, change it to u. So integration has limit, lower limit, higher limit. If it was in x, change it to u, and then everything is all right. Or whatever integration came in u, get it back into x, and then do the integration. So if integration limit is minus a to a, what about this? So it is now it is sine square. Now sine square u du, integration of sine square u is u by 2 minus sine 2u divided by 4. Okay. Now u by 2 minus sine 2u divided by 4. Now I have to bring it back to the kind of to the x part. So x equal to a cos u equal to x by cos inverse x by a. I have already given it. So u by 2 would become cos inverse x by a divided by 2 minus sine 2u. U will become cos inverse x by a sine 2 cos inverse x by a by 4. Okay. So now it came in x, minus a to a is the limit. Integration is done, right? And then now cos inverse x by a minus a to a. If I set a cos inverse a by a 1, that is 0. First term 0. Second term sine 2 0 0, all gone. Lower limit is minus a. Now minus outside, minus gone. Now a square is outside. Now a and sine inverse minus x by a, minus a by sine inverse minus 1 pi by 2, and then sine pi 2 pi 0. So pi by 2. So it is pi by 2. So now it is the net integration is pi a square by 2. This is the actually area of the semicircle. Full area is pi a square. If someone is not satisfied with this, then he can try changing the limit. So net integration was u by 2 minus sine 2u by 4. Then change the limit. It was minus a to a. If x is minus a and x equal to a cos u, then u would be pi. And if it is a, then u would be 0. So pi to 0. Same result would come. So this is called parameterization. Parameterization in the sense x equal to a function of g, and inside that there is a parameter u, x equal to gu, whereas we had y equal to fx. So that was another parameterization, y equal to fx. Now x equal to gu means we are saying we are using method of substitution in integration, where x independent component again substituted with another independent component u. X became dependent here. We are using, this is called delegation in designing. If you do designing in software, this is called delegation. We are delegating our computation to third party which knows how to use the delegation. Delegation can be actively used, like I have to shuffle a number. If I have a number 1, 2, 3, 4, can you get all the permutation of number that comes through shuffling? 1, 2, 3, 4, 1, 2, 3, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, whatever combination is coming. Now it is considered it is an assignment and try the delegation to make the permutation combination of a number, whatever it is. Now this is how it is. Now question arises is, can I find a parameter of a curve? That is the question. Parameter of a curve. If I try to calculate parameter of a curve, okay, so if I try to calculate parameter of a curve, if this is the curve, what is the parameter of a circle? So if this is the circle, this is what example we have given already. If this is x-axis, then any point here in x comma y in xy plane, then this is position vector xi plus yj. This is also x comma y. This is also x comma y. Position vector would move because x comma y is algebra, where x comma y I can think of x0 y0, x1 y1, x2 y2 like that. X comma y is variable. So position vector is xi plus yj. Now how I can calculate the length of this curve? So we have already talked about it. So length of this curve, if I try to find, then I can calculate the velocity vector, because displacement is nothing but integration of the velocity. Velocity is nothing but integration of the acceleration. Velocity is nothing but derivative of differentiation of displacement. It is that way. So if I have a velocity vector along this curve, and if I integrate that, then I get the length of the curve. So if I have a position vector xi plus yj, then dp by dx, that is a velocity vector, x being only one independent component. So dp by dx would come as I plus dy by dx j. These two would be orthogonal, p and dp by dx. We tried that. So x plus dy by x plus y into dy by dx would be 0. Now y x plus dy by dx into x plus y into dy by dx, that is the dot product of these two. Y is square root of a square minus x square. Dy by dx is minus x divided by square root of a square minus x square. Net would come x minus x equal to 0. So p and dp by dx, position vector differentiation, if this is position vector, differentiation vector would be perpendicular to the position vector. Okay, this is position vector, then it is exactly perpendicular and it will move like on that as a tangent on the surface. This is velocity vector. If I integrate this, I get the length. So what is dp by dx is I plus dy by dx j. If that is the case, then what is the magnitude of this velocity vector? That is 1 square plus dy by dx whole square root. So that is 1 square plus x square divided by square root of a square minus x square divided by a square minus x square whole root. This is the power of the velocity vector integrating along dx, because if velocity vector is there, if I integrate, I get the displacement. From here to here, from here to here, minus a to a, minus a to a, it becomes it becomes a by square root of a square minus x square dx. So that is the kind of differentiation that I have to do. 1 by square root of a square minus x square dx. Now here I have to use the method of substitution, or a kind of method of substitution or parameterization. Can I take x equal to a cos theta? Unknowingly, we are entering into polar coordinate system. We are taking help of polar coordinate system. So if that is the case, then it becomes a by a cut down 1 by sine theta, and dx is dx by d theta into d theta. That is Jacobian, dx by d theta. So dx by d theta here is a minus a sine theta. So sine theta also gone. Minus a remained. So minus a I can keep outside, sine theta d theta. Then its integration is minus cos theta. Minus again gone. So a and then cos theta. Cos theta, a equal to a, x equal to a cos theta. So a equal to x equal to a cos theta. Cos theta equal to x by a. So now I can place it as x by a. I believe I am not making any mistake. Okay, so it will be cos theta equal to x by a. Certainly I am making some mistake because the length of the pi, it will have some pi. So cos theta is the net integration we are receiving. I'll try again. So we have integration magnitude of this dp by dx, that is the curve length. Then magnitude is 1 plus 1 plus and then x square divided by a square minus x square whole root. Then it will go and it become a by square root of a square minus x square. A by square root of a square minus x square. X equal to a cos theta. A would come out, top a, bottom a gone, and 1 minus cos square theta will be sine theta. 1 by sine theta. Now dx is dx by d theta, that is Jacobian into d theta. So dx by d theta is a minus sine theta d theta. So if that is the case, sine theta also gone, minus a remained there. Minus a I can keep outside and sine theta d theta. So correct, then it is integration of sine theta is minus cos theta. So minus minus gone. Cos theta is the net integration. Cos theta is the net integration. And then x is from minus a to a. What is if I change this limit? First I try to change so I will have some confidence. So first try to change the limit from minus a to a, that is x, to in theta fashion. So x equal to a cos theta. So x is a, then theta is 0. When x is minus a minus 1, then theta is pi. So pi to 0. Pi to 0 and pi to 0, and that is cos theta. Okay, pi to 0. So now pi to 0. Pi to 0. Again I am making some mistake because it would result not in the pi. Again it would result not in the pi, and we will have something that is the we are trying to calculate perimeter here. So what mistake I am doing? Let's try again. A by square root of a square, a by square root of a square d a square, a by square root of a square minus x square dx. X I have kept a cos theta. So a would come out, a by a gone, 1 by square root of 1 minus cos square theta, sine theta, sine theta, and there a cos theta. Cos theta integration is minus sine theta. So minus a gone, sine theta gone, and minus a remain. Minus a I can keep outside. Integration is only for the d theta. Everything is gone out. Now it is correct. D theta. If it is d theta, integration is theta. Now I can bring back theta into Cartesian coordinate again. So theta is nothing but cos inverse x by a. So cos inverse x by a minus a to a. So now it would be pi. It would be pi. So minus was outside. So it would be pi. So pi a. A was there, so pi A. So pi A is the parameter from half. So full parameter is 2 pi A. Or if the integration was theta, I can switch the limit minus A to A. So if x equal to A cos theta, then minus A is pi and A is 0. Then same thing will come as minus pi. Minus minus outside gone, and it is pi A. Full parameter is 2 pi A. So we calculated it. So here we use the parameterization. Now question arises is we used vector, right? I have a position vector that is xi plus yj. Now if I change this x into a, at the end we change the dx, x dx after at the beginning only can I do the parameterization in the vector itself? That is the question. That's why this session is, can I do parameterization in the vector itself? This is called parametric vector. If I have a vector p equal to xi plus yj, then this is typically called px, a vector which is of function x, xi plus a square root of a square minus x square j, full function of x only. Now, I don't know how to proceed, so I will take x equal to a cos theta, x equal to a cos u, x equal to a cos u. Now, x is dependent and u is independent, a is static. Now, this vector is changed into r vector. This is called parametric vector. R, on top of it one arrow mark vector, and in function u. R as a function of u, it is a vector. It is parametric vector, vector field, whatever you call it. R parametric vector is a function of u equal to a cos ui plus square root of a square minus x square j, a sin u j. Now can I calculate parameter again through the kind of this parametric vector? Now earlier we had the kind of, if you remember, the parameter was dp by dx, magnitude of dp by dx, dx. So here same way, instead of dx magnitude, the dp by dx we were calculating. So now we have in variation of u, x is gone. I have a full-fledged vector r vector as a parameter of u, ru, and then that is a cos ui plus a sin uj. What is this? Now I have two coordinate system. One is u coordinate system. You can say as coordinate system that is similar to u and function of u. I won't say u v or something like that. I have a coordinate system where independent variable x axis generally you say then u and function of u. There is another coordinate system x and function of x. So x and function of x is called yx plane. Now here I have u and function over u is fgu, that is x. So xu plane, yx plane. So there are two planes. Now question arises is if I have a point u and u I make a slight change, minute change, then I have a function that is x equal to gu, function over u is x. If I bring a slight change in u, then how much change I see in x, dx by du. This is called Jacobian, dx by du. If I have two coordinate systems, one is u and function of u, one is x and function of x. X and u are related through a function called g. If I take any point u and make a slight progress in u, that is delta u, then how much delta x is seen? Dx by du. Okay, anyway, I have now parametric vector. Now I had a circle that was defined by x and function over x. That is that is function over x is square root of a square minus x square. If I take any position vector, then it is xi plus a square root of a square minus x square j. Now this circle is transformed into another plane called u plane. There it may not be a circle. Means a circle in xy plane, if I see a xu plane or uv plane, the relative is famous for uv plane, then the circle in xy plane may not map to uv plane as a circle. It may be a rectangle, whatever it is. Now, whatever is the case, now the question arises is that what is the, if I have a vector that is a cos ui plus a sin u j, or vector parametric vector r function of u equal to xi plus yj. That was the initial. Now this vector, if this, what is the velocity vector for this? Dr by du. It is a function of u. Dr by du. That will be nothing but, that is nothing but a cos u, dA cos u by du I plus dA sin u by du, or dx by dui plus dy by duj. And then the magnitude of the this d dx by du whole square plus dy by du whole square, a square root, and then its integration over, then its integration, then its integration over du, integration over du. Okay, so integration, because we are taking it into u form. So if that is the case, now it is u du cos theta by du is is minus u sin theta I plus du sin theta by du, then it is u then it is u cos theta. Then if I calculate its magnitude, then it becomes u. It becomes u. Okay. So magnitude of minus u cos theta, u sin u minus u sin theta I, and u cos theta j would result in square root of square root of a square and a square root. It would become u. It would become u. And then if it becomes u, then what, if this is the magnitude, if this is the u is the magnitude, then what would be the net integration with respect to du? Okay, so now if I integrate u with du, it becomes u square by 2. Okay, integration of u, integration of u, I believe I am correct. I'm sorry, it is a cos square u, a cos, I'm sorry, dA cos u by du I plus dA sin u by du j. The magnitude of it is a. I can keep outside, then integration of du, because we are taking now in the full form of du of parametric vector r with u vector. So r with u vector is nothing but a cos ui plus a sin uj. What is dr by du? Earlier we had dp vector with a parameter of x. So p vector with x was xi plus the square root of a square minus x square j. dp by dx was I plus then minus x by square root of a square minus x square j. Magnitude of this integration with dx gave me the length. Here I have another function, that is ru. R vector u is nothing but a cos ui plus a sin uj. Now differentiation is with u, then it will give me a minus sin ui plus a cos u j. its magnitude would result in a. A I can keep outside, and then integration with du. That is another plane we are talking about. Now integration of du would be u. So u that we have to calculate, that would go from pi to 0, because that is what the initial was. X was a cos u, means if x is minus a to a, u would be pi to 0. So here u pi to 0 would result in pi. Net integration is pi a, and parameter of a circle is 2 pi a. This is vector form. In vector form, we did not calculate the Jacobian. Otherwise, we need to translate it into Jacobian. So if I have dx, then dx by du into du. So if I have everything in Cartesian coordinate, full integration is in Cartesian coordinate, and I want it to happen through another coordinate, that is u coordinate, then dx will be transformed to dx by du into du, and x would be transformed into the way I have taken x equal to gu. But in vector form, you just need to modify x, and then you get the vector in term of u only. Okay, and then if you get vector in term of u, then dr by du would give you the velocity vector. Calculate the magnitude of velocity vector, and since everything in u coordinate system, just integrate by u and set the limit, you get the length of the of this kind of a circle. So now we are moving to in parameterization, we are moving towards parametric vector, Jacobian parametric vector. We will move more in it as far as surface is concerned. Only line we are talking now. Only line. Surface we will talk where it will be, here it is xy plane, then here it is full place uv plane. Now x is a function of u and v, x equal to guv. Y is a function of u and v, y equal to huv. In that case, how we proceed? The life was easy. I had a plane that is u and function over u, x and function over x. Only one independent component, x and u. Now I have two independent components, x and y, both are independent. That is surface. XY plane, both x and y are independent, where dependent is function over x and y. If xy plane is mapped into 3D, into UV plane, then u and v are independent. UV plane, and upon u there is a GUV. Again upon UV there is a HUV. GUV is x and HUV is y, where x and y, they are again independent in some other coordinate system. Very complex. Whatever it is, we calculated the parameter of circle through Jacobian dx by du, and then by pure parameterized vector. So first parameterization we used, and then parametric vector we used. Both we calculated. Same thing we will see in 3D. So that we will see.